Welcome back to the deep dive. Today we're stepping away from the front end and heading into the back rooms, the wiring closets, the server racks.
The places where all the magic happens, or sometimes where the headaches start.
Exactly. We're tackling the, let's say, complex world of large-scale video distribution.
Could definitely get complicated fast.
Specifically, our source material is all about the WolfPack 4K 30 Hz AV-over-IP matrix switchers.
Right.
And when we say large scale, we really mean it. These systems are designed for managing video across, well, potentially dozens of displays. The specs mention up to 90 TVs in one go.
That's a serious amount of video to wrangle.
So our mission today is to unpack how this tech handles that kind of massive distribution, but maybe, just maybe, keeps the underlying infrastructure relatively simple and affordable.
That's the key challenge, isn't it? Scale versus complexity and cost.
It is, and I have to admit, when I first saw the headline feature, I was pretty skeptical. Delivering 4K video live streaming over a standard, maybe even existing, 1 gigabit Ethernet switch.
Yeah, that often raises eyebrows.
Right. Forget needing special fiber or, ripping everything out for 10G infrastructure. This claims to work over regular copper network cables. It sounds almost contradictory. How are you squeezing huge 4K video through a relatively small 1G pipe?
Well, it's a really interesting technical approach they've taken. It's actually quite elegant. They rely on a couple of key things to make 4K possible on that 1G network.
Okay.
First, they're specifically targeting 4K resolution, but at 30 frames per second, 30 hertz.
Not 60 hertz.
Exactly. That frame rate ceiling is crucial. It keeps the total data load more manageable right off the bat.
Ah, okay. So that's compromise number one. What's the second part?
The second part is using really efficient compression. The specs mention the H.265 protocol.
H.265, right. Seen that before.
Yeah, and it's essential here. It dramatically cuts down the bitrate needed for high-res video without, completely destroying the visual quality.
So if they tried for 4K 60 hertz...
Oh, then you'd absolutely need a 10G network backbone, no question. And that bumps up the cost of switches, cabling, everything significantly.
Gotcha.
So by optimizing for 4K at 30 hertz and using that strong H.265 compression, they unlock this big economic advantage. You can use the 1G infrastructure that, frankly, many places already have installed.
That makes a lot of sense. It's a smart trade-off defining the system's efficiency. And speaking of efficiency, the whole architecture leans on standard network ideas using this 4K 30 Hz AV over IP PoE technology. Can you break down PoE for us in this context?
Sure. PoE is power over Ethernet, and it's a really big deal here.
Why is that?
Because it means every single endpoint device in the system, the unit sending the video and the unit receiving the video, gets its power directly through the same CT6 network cable that carries the video data.
Oh, wow. Okay.
So think about it. No need for a separate power outlet and power brick in every single TV or display location. That massively simplifies the installation. Less wiring, less complexity, lower labor costs. It's huge.
Yeah, I can see that being a major plus on a big install. Okay, let's make it concrete. The sources give an example, a 14 by 32 system. So 14 inputs going to 32 different TVs or outputs.
Right.
So that would mean you need 14 of the input boxes, they call them transmitters, TX units, and 32 of the output boxes, the receivers or RX units. Now, if I'm managing a facility, stocking 14 of one thing and 32 of another, that sounds like a bit of a logistical pain, inventory, spares.
Yeah, it absolutely could be. Keeping track of 2 different hardware types, managing spares for both. Yeah, it's not ideal. And that's why the sources highlight what might be the cleverest design choice in this whole system.
Okay.
The transmitter, the TX unit, and the receiver, the RX unit. Yeah. They are actually the exact same physical piece of hardware.
Wait, what? How can one box do 2 totally different jobs, sending versus receiving?
It's the beauty of software-defined hardware, really. The physical unit is technically a transceiver. It can transmit or it can receive. When you deploy it, you plug it in, connect it to the network switch, and then through the system software, you just tell it what its job is. You select TX or RX. Okay,
that is genuinely brilliant.
Isn't it? It means the facility only needs to buy and stock one single type of box, one SKU, for every input and every output. It future-proofs your spares inventory and makes troubleshooting way simpler.
One box to rule them all, basically. Buy a pallet of these things, and the software sorts out their roles. So once you have all these transceivers hooked up, how do you actually, tell the system what to do? How do you route signals from input 5 to TV 27?
The control side is designed to be pretty accessible. You can use PC control software for configuration and management.
Right.
But the main way, the more common way highlighted, is through native apps for iOS or Android. So operators can manage the entire matrix, all the routing, just using a standard tablet or even a phone.
Convenient. Okay, let's pivot from the individual boxes to the sheer scale, because managing, say, 90 TVs from one system is, well, it's massive.
It really is.
The sources are pretty bold here. They use the term unlimited quite a bit. Unlimited sources, unlimited computers, USB and KVM support, unlimited HDMI ins and outs. Now, is that just marketing speak, or is there some technical grounding for this unlimited idea?
It's less marketing hype and more a reflection of the underlying network architecture. It gets around the physical limits of traditional matrix switchers.
How so?
Well, think about an old school matrix. It's a physical box with a fixed number of input and output ports. A 32 by 32 chassis is physically limited to 32 ins and 32 outs. That's it.
Right, the box size is the limit.
Exactly. But here, because the video is converted into IP data packets traveling over a standard network, they achieve massive scale by supporting the cascading of multiple Ethernet switches.
Cascading, so linking switches together.
Precisely. Imagine your main 48-port PoE switch as the brain. If you need more TVs, more inputs, you just take another standard, off-the-shelf 48-port switch, plug it into the first one, and the WolfPack control software automatically sees both switches and all the transceivers plugged into them as one single, unified, enormous matrix.
Ah, I see. So it breaks free from the limitation of one central hardware box.
Completely. It makes the system genuinely unlimited field upgradable.
Yeah.
Just keep adding standard network switches as your needs grow.
So the installer isn't forced to run every single cable back to one giant rack in one room. They could put smaller, cheaper switches out closer to clusters of TVs, say on different floors or wings.
Exactly.
And the system still sees it all as one integrated routing fabric. That distribution must be a huge cost saver on the installation side for big commercial spaces.
It absolutely is.
Yeah.
That distributed architecture lets them deliver on the core promise of a true matrix switcher, which is any inputs, any output, anyway, you want it, total flexibility.
Okay, let's talk performance. We know it's 4K 30 Hz using H.265 compression, but what about the actual user experience? You know, lag is always the enemy. What's the switching speed? How much latency are we talking about?
The sources cite 80 milliseconds for both switching speed and overall latency.
80 millis, is that good?
For distributing video live over a 1G copper network like this, 80 millis is actually very, very good. It's generally considered barely perceptible to the human eye. So when you switch channels or sources on a display, the experience should feel pretty much instantaneous, very fluid.
Okay, that's reassuring. And the physical side, again, cabling. We mentioned CT6. And how far can you push that signal?
Yep, standard, widely available, inexpensive TT6 cabling. And the maximum extension distance is substantial, 450 feet.
450 feet, that's quite a distance.
It is. It's more than enough to cover really large commercial venues, think big box stores, airport terminals with digital signage, sprawling hotel conference centers. It easily surpasses what you can do with just standard HDMI cables or even many older extension methods.
We touched on HD65 earlier. What about other key compliance points? Anything mentioned in the specs?
Yeah, they cover the important bases. It's HDCP compliant.
Which you need for things like Blu-rays or cable boxes.
Right.
Protected content. Yeah.
Exactly. HDCP compliance is non-negotiable for most commercial uses. They also specifically mention SEC security compliance.
Okay.
These aren't trivial details. They ensure the system meets the requirements for deployment in corporate, government, or other environments where content protection and network security are paramount.
Good points. And now we get to something that probably makes business owners' ears perk up. The cost structure. The sources make a point of stressing a key benefit: no monthly license fees.
And that right there can fundamentally change the whole financial picture, the total cost of ownership, for a big deployment.
How so?
Well, in the world of professional AV and digital signage, it's pretty common for the software that manages these complex systems to come with ongoing subscription fees. Sometimes it's per screen, sometimes it's an annual license for the whole system.
Right, the SaaS model hitting AV.
Pretty much.
Yeah.
And if you have, say, 90 screens running for 5 years, those recurring license costs can really add up. They can even end up costing more than the initial hardware investment over the long term. So this system's approach, being structured as a capital expenditure, you buy the hardware, you own the software, no ongoing fees, that eliminates a major operational expense. It makes budgeting much more predictable.
That is huge. Yeah, that strengthens the argument for this AV over IP method compared to older systems, especially those locked into proprietary hardware and software licenses.
Definitely a big financial draw.
Hey, let's shift focus again. Let's think about the person actually using this day to day. The manager on the floor of a restaurant or bar trying to juggle 14 different input sources going to 90 different screens. What features make their life easier?
Probably the single most valuable feature they highlight for the operator is the iPad real-time video preview of all sources.
Real-time preview. What does that mean exactly?
Imagine you've got, like you said, 14 inputs. Maybe they're DirecTV boxes, a couple of Blu-ray players, some digital signage PCs.
Yep.
Without a preview, if you want to put the big game from DirecTV box #3 onto TV Shack 12, you're kind of guessing. You select input 3, hope it's the right one, send it to the TV.
Right, trial and error.
Exactly. But with the real-time preview, the control app on the iPad or tablet shows a live, moving thumbnail image of what's currently playing on every single one of those 14 sources, all on one screen.
So you can see exactly what's on each input before you route it anywhere.
Precisely. It takes the guesswork out completely. The operator just looks at the grid of live previews, taps the thumbnail of the game they want, and then taps or drags it to the icon representing TVF #12. Done. It's visual management. It drastically reduces mistakes and speeds up changes.
That sounds incredibly useful, especially in a fast-paced environment. Now, what about video walls? Those are often a headache to configure. How flexible is this system? Are you locked into standard grids like a 2x2 or 3x3?
Not at all, apparently. Because the video processing and routing is all handled in software over the IP network, they boast support for multiple video walls of any size and any quantity.
Any size, so like a long, skinny 1x5 video wall, or an irregular shape.
Seems so. The software should handle the complex pixel mapping needed to stretch a single source across various arrangements of displays. Whether it's a standard grid, a vertical banner, maybe even a creative non-uniform layout, it offers a lot more freedom than traditional video wall processors that are often hard-coded for specific matrix sizes.
Interesting. You also mentioned connectivity earlier, the transceiver units having 3 USB ports and separate audio outputs. Let's unpack the USB part. The sources mention KVM. What does that enable?
Right. KVM stands for Keyboard Video Mouse.
Okay.
So imagine some of your video sources aren't just passive feeds like a cable box, but they're actual computers, maybe running digital menu boards or corporate presentations or information kiosks. Normally, that computer might be locked away in a server room, maybe hundreds of feet away from the display it's feeding. KVM over IP, using those USB ports on the transceiver near the display, lets you plug in a standard keyboard and mouse right there at the screen.
And control the computer back in the rack.
Exactly. You get remote control of that distant computer as if you were sitting right in front of it. It's essential for managing interactive displays or updating content on source PCs without having to physically go to the machine.
Seamless remote access. Got it. And the separate audio outs. Why is that important?
That's critical for most commercial audio setups. In a bar, restaurant, or large venue, you almost never want the audio just coming out of the individual TV speakers.
Right, you want it going through the main sound system.
Precisely. You need to feed that audio into a centralized amplifier and speaker system, often with different audio zones. The separate audio output on the receiver unit lets you route the video signal to the TV's HDMI input, while simultaneously sending just the audio feed out to your professional audio mixer or distribution amplifier. Keeps video and audio paths independent and controllable.
Makes sense. Okay, this brings us to a really specific application the sources highlight, which kind of ties a lot of these features together. An optional add-on called the Sports Bar System.
Yeah, this sounds like a targeted solution package.
It seems like it goes way beyond just switching video signals. It's pitched as more of an entire ecosystem controller for that specific environment.
Right.
Think about the typical sports bar on a busy game night. You've got maybe 20, 30 TVs, a stack of cable or satellite boxes, maybe some streaming devices.
A handful of confused staff juggling 15 different remote controls.
Total chaos. Trying to get the right game on the right screen for the customer who just asked, this add-on seems designed to eliminate that exact scenario.
It looks like it aims to consolidate everything onto that one tablet interface. The optional integration lets the user manage the entire entertainment lineup, not just the video matrix.
So more than just routing video.
Yeah, the description says the app can control volume levels, manage all the video switching, and allows the operator to change DirecTV, DISH, cable, and even Roku channels directly from the app.
Whoa, so no more hunting for the DirecTV remote for box number 7.
Apparently not. It also mentions being able to visually display the floor plan of the venue within the app, showing where every single TV is located.
Okay, that's cool.
And integrating all TV listings directly into the same interface. So the manager can see the floor plan, see what's currently playing on the guide for all channels, tap the game they want, and then just drag it to the icon representing the specific TV or video wall.
It basically transforms that frantic 5-minute remote shuffle into maybe a 2-second tap and drag operation on the tablet.
That seems to be the goal. Unifying control, simplifying operations, especially in high-pressure, high-turnover service environments.
That unified control is a massive value proposition there. And what's surprising, maybe, is the accessibility. Control is via standard Wi-Fi apps you mentioned,
Right.
and the price for the core hardware, the base transceiver unit, the build-your-own component. The source is listed at $250.
Yeah, that $250 price point for the fundamental building block, the transceiver, is really what makes the whole unlimited scalability idea economically feasible.
Because you're not shelling out thousands every time you want to add just one more screen or one more source to the network.
Exactly. It keeps the incremental cost of expansion relatively low.
Okay, so let's try and wrap this up for you, the listener. What are the big takeaways here? We've seen that this WolfPack technology offers pretty powerful, highly scalable 4K video distribution, specifically at 30 Hertz.
Using efficient H.265 compression.
Which crucially allows it to run over standard, often already existing, 1 gigabit network infrastructure. Big cost saver there.
Definitely.
It's managed by intelligent software that not only routes signals, but actually defines the hardware's role, that clever TXRX transceiver concept.
Right, the single hardware unit.
And it offers deep control features like the real-time preview and the optional integrated source control, which are really valuable in complex commercial settings. It feels like a merge between enterprise AV needs and more accessible IP networking principles.
And maybe one final thought, connecting back to the bigger picture for anyone considering this kind of system as a long-term investment. Credibility and support matter.
Good point.
The provider mentioned HDTV Supply, Inc. isn't new to the game. They've apparently been certified since 2003 with something like 24 years in business. Their product names, WolfPack and WolfPad, are registered trademarks. And importantly, they're listed as an HDBaseT.org approved adopter.
So they're involved with industry standards bodies.
Right. That kind of established presence and adherence to standards provides a level of confidence. You're not just buying into a proprietary black box. There's some institutional backing suggesting longevity and interoperability.
That stability is definitely important for infrastructure decisions. Okay, so our final provocative thought for you, the listener, as you mull over this shift towards AV over IP for large-scale video, think about the combined economic impact of those two core features we discussed. First, the solid 4K 30 Hz performance with low latency running over standard 1G networks. And second, that single software-defined transceiver unit replacing separate TX and RX boxes. How does that fundamental change in inventory management, combined with the complete elimination of recurring monthly software license fees, reshape the entire financial equation? How does it change the way you'd budget for, operate, and potentially expand a complex video network in your facility compared to the traditional ways?
That's a great question to ponder. It really shifts the cost model significantly.
Something to think about. Thanks for diving deep with us today on AV over IP.
Always interesting stuff.
We'll catch you next time on the